Hi guys, welcome back to the channel. Today I'm going to show you how to solve this problem 10-24 and 10-25. It says determine the moment of inertia of the area about the x and y axis. So let's get started. In order to determine the moment of inertia, we have to use the definition for the differential element. So the ix will be equal the integration or the integral of y squared times dA. Okay? This is the moment of inertia about x-axis. So if I would like to determine the moment of inertia about an axis, we have to use the parallel axis theorem. So I have to draw a differential segment which is parallel to the axis of interest. Okay. As you can see, I draw a rectangle that is parallel to the x-axis, and I will call this element dy, small thickness dy, and this area will be, or this height will be x. Okay. This area, infinitesimal area, which is dA. Okay. Substituting ix will be equals to y squared times dA. The dA will be x times dy. X times dy. From where to where? From minus r naught to r naught. Okay. Minus r naught to r naught. Now I have to represent the x in terms of y to do the integral. So x will be equal to the square root of r naught squared minus y squared. Substituting, getting ix from minus r naught to r naught, y squared times the square root of r naught squared minus y squared dy. I substituted x. So if you would like to integrate this expression, we will have to use a trigonometric substitution. I'm going to let y will be equal r naught sine theta, and dy will be equals r naught cosine theta d theta, and that's it. Okay. Substituting y and dy, yielding ix, the integration y squared, which is r naught squared sine squared theta times the square root r naught squared minus r naught squared sine square theta times cosine theta d theta. Doing some manipulation, r squared times sine square theta, that's square root, taking r squared common factor, will be 1 minus sine squared theta times cosine theta d theta. Doing some manipulation, this part is cosine square theta, and taking the square root of both segments will yield r naught squared times sine square theta. This will yield cosine square theta times r naught square theta will be r naught times cosine theta times cosine theta d theta, yielding r naught cube sine squared theta times cosine squared theta d theta. Now what I'm going to do, I'm going to replace sine theta by an expression r naught cube outside, 1 minus cosine squared theta times cosine squared theta d theta, yielding r naught cube, the integration cosine squared theta times d theta minus the integration of cosine to the 4 theta d theta. To solve this integral, we will use the angle theorem. will yield r not squared, r not cube times the theorem indicates that cosine squared theta will be equal 1/2 times 1 plus cosine to theta d theta, and then we have minus here, which is r naught as well, r cube, because the r cube will be multiplied by through the whole integral as previously did, and cosine square to the fourth theta will be equal to the cosine square theta times cosine square theta, which is 1/2 times 1 plus 1/2 cosine 2 theta squared d theta. I'm gonna insert extra page. I'm gonna take r cube theta times 1/2 plus 1/2 cosine 2 theta d theta minus r naught cube 1/2 times 1/2, which is 1/4. I'm going to do the multiplication. 1/4. 1/2 times 1/2 cosine 2 theta will yield 1 to the 4th cosine 2 theta, and then cosine 2 theta, and then 1/2 cosine 2 theta times 1/2 will yield plus 1/4 cosine 2 theta, and cosine 1/2 cosine 2 theta times 1/2 cosine 2 theta will yield 1/4 cosine 2 theta squared. Excuse me, this should be cosine to the 4th cosine 4 theta, okay? 1/4 times cosine 4 theta times d theta. Doing some simplification, r cube integral 1/2 plus 1/2 cosine 2 theta d theta minus r cube 1/4 plus 1/4 cosine 2 theta plus 1/4 cosine 2 theta is 1/2 cosine 2 theta plus 1/4 cosine 4 theta d theta. Taking the integral will yield r cube 1/2 times theta plus 1/4 sine 2 theta. Taking the integral of this, because I took r cube common factor, so I will not write r cube again, minus 1/4 times theta minus 1/2, I mean 1/4, the integration of 1/2 cosine 2 theta, which is 1/4 sine 2 theta, because I have a minus sign here, minus 1/, divide this by 4, which is 1/16 cosine, sine 4 theta. This is the whole integral. Doing some substitution, I'm going to draw a triangle, represent everything in terms of r and x and y. This is, I called sine y equal r sine theta, which means that this is y over r naught, this is r naught squared minus y squared, okay? Doing some substitution, knowing that sine theta is y over r naught r cube 1 over 2 times theta minus 1 over 4 times theta will yield 2 times 2 over 4 minus 1, yielding 1 over 4, yes. Yielding 1 over 4 times theta, and theta will be equal sine inverse y over r naught. I took this and this. Now having 1 over 4 times sine to theta and sine 1 over 4 times sine to theta minus 1 over 4 times sine to theta, these parts will cancel, and remaining with minus 1 over 16 sine for theta minus 1 over 16 sine for theta, knowing that sine to theta will yield 2 sine theta cosine theta. Having sine for theta 4 times sine for theta, what will be? Let me check. And yes, I got back cosine 4 theta will equal to 2 sine 2 theta times cosine 2 theta. Two sine 2 theta cosine 2 theta. And how can we solve this expression? R naught cube 1 over 4 sine inverse 1 over r naught y over r naught minus 1 over 8 sine 2 theta, which is 2 cosine theta, 2 cosine theta sine theta cosine 2 theta, which is 1 minus 2 sine square theta, and yielding r naught cube 1 over 4 sine inverse y over r naught minus 1 over 4 cosine theta. What is cosine theta? From this triangle, cosine theta is adjacent over hypotenuse, which is square root r naught squared minus y squared over hypotenuse, which is r naught. Yes. And sine theta will be equal y over r times y over r naught, then 1 minus 2 sine square theta, which is 2 y squared over r naught squared. This is the final answer, and let me continue doing some manipulation. And I'm going to integrate actually from minus r naught to r naught. R naught cube 1 over 4 sine minus 1 sine inverse, I mean y r naught over r naught over r naught, which is 1. Let me check. Which is 0. R naught over r naught 0. This expression will be 0. Minus 1 over 4 r naught, this expression will be 0 as well. R naught will be 0. So let's substitute minus R naught. This part will be 0 minus R naught, okay? This part will be 0. This part minus 1 over 4 R naught squared minus R naught squared minus R naught squared, which is 2 R naught squared over R naught. squared. We have here R naught over R naught. This will cancel, yielding R naught alone times 1 minus 2 minus R naught squared over R naught squared. This cancel, so 1 minus minus, which is 1, and the final answer will be a minus minus 2, which is plus 1, 3. So R naught cube times minus 3 over 4. This part will cancel, because here if we take the square root 2 R naught over R naught, this will cancel, and this is the final answer. Okay, Ix will be minus 3 root 2 over 4 times R naught cube. This is the final answer for Ix. If you would like to substitute this, it was not solved, by the way, as you can see, and let me go back to the question. The answer, and thanks for watching. I will solve IY in the next video, and see you later.